From the subatomic to the solar system, from our planet to the depths of the cosmos, the same elements are scattered through the stars, through every galaxy. Common matter forms everything, and all of us. Once this profusion and confusion did not exist. There was nothing. No matter, no radiation, no space, no time. Some reject the theory, but most cosmologists agree the universe was born of a Big Bang. But while they can explain how, they have no idea why. From the Big Bang, from an infinitesimal speck, the universe exploded. Not into space, because there was none, but inflating within itself. Today, that expansion continues, the space between galaxies ever widening. The Big Bang was some 14 billion years ago. In the first trillionth of a second, time, space, and matter grew 100 million times to less than the size of an atom. Then, in another instant, and more dramatically, they were as big as a galaxy. The universe was a soup, so hot that energy generated matter and antimatter as massive particles. As they decayed into lighter ones, matter triumphed over antimatter by 1 part in a billion, but enough to yield us the cosmos. By now, the temperature had dropped to 1 trillion degrees Celsius. When the era ended, the universe was just 10 millionths of a second old. Physicists simulate that era with an atom smasher. 2 rings accelerate particles, called heavy ions, in opposite directions. At intersections, close to the speed of light, beams of ions collide with tremendous energy. They produce showers of subatomic particles. The accelerator at America's Brookhaven National Laboratory is 4 kilometers round. Within, for an instant, a curtain lifts on the embryonic universe. We're in a plasma of subatomic particles, of quarks and gluons. At 1,000th of a second after the Big Bang, quarks and gluons were forming protons and neutrons. Then at 1 second, and down to 1 billion degrees, protons and neutrons were making atomic nuclei. At 3 minutes came the first elements, hydrogen, helium, and a little lithium. Electrons, here in blue, were tamed during the next 350,000 years, captured in closed orbits around nuclei. Temperature was down to 3,000 degrees. When electrons were locked into atoms, they no longer blocked the passage of light-bearing photons. All of a sudden, the fog cleared. The universe became transparent. And so began the matter-dominated era. From clouds of hydrogen and helium gas formed galaxies. Galaxies formed clusters, and clusters formed filaments. It goes on to this day, ever expanding, ever cooling. This expansion is the prime evidence for the Big Bang. But there's more. From 350,000 years after the Big Bang, when the cosmos became visible. It's called cosmic background radiation, and it pervades the universe. In 1965, it was discovered by accident as a faint microwave hiss. This antenna picked it up from every direction in the sky. From near infinite heat, the universe had cooled to 3,000 degrees when the radiation was emitted. It originated as ultraviolet radiation, but shifted to microwave as the universe expanded and cooled. Today, the cosmic temperature is just under minus 270 degrees. In 1992, COBE, the Cosmic Background Explorer, was the first to make sense of the microwave hiss. COBE took the temperature of the entire sky. Different colors were fluctuations of a few millionths of a degree. This launch in 2001 brought COBE measurements into sharper focus. The probe, known as WMAP, orbited around nothing. It wobbled because of the pull of the planets. At 1.5 million kilometers out, WMAP was free of microwaves and magnetic interference from Earth. From its stable thermal environment, the probe worked with its back to the Sun, the Earth, and the Moon. Results were remarkable. By eliminating the red band, the strong and superfluous signals of our galaxy, WMAP had charted the cosmos in microwaves, with new insight. On the left, compare COBE's fuzzier map. Now with WMAP, observe the detail, see the ripples. Like a pebble in liquid, ripples on the left in oil differ from those on the right in water. The medium determines the ripples. And so do the number of pebbles, plus their size and mass. These ripples are like density variations in the early universe. Expansion from the Big Bang wasn't smooth. Matter rippled and clumped. WMAP's temperature chart revealed that clumping. Here were the seeds of the large-scale structure of the universe. The structure resolved within 1 billion years. Galaxies clustered along frothy filaments. Between them, voids of space ever widened. And stars were born. All over the universe, lights came on, as one astronomer put it. Everywhere, gas was condensing and heating to initiate nuclear fusion. This first generation of stars was hotter, brighter, and more massive than the supergiants of today. Now, generations later, galaxies swarm in superclusters where filaments intersect. This cellular structure was set by density fluctuations in the infant universe. Their detection was through cosmic background radiation. The 50 billion or so galaxies of the universe are its building blocks. Most galaxies are gregarious, from groups of a few dozen to clusters of thousands. Bound together by gravity, one of the most massive is this galaxy cluster. Here in simulation, the evolution of a cluster over 10 billion years. Galaxies collide and merge. Most astronomers believe clusters grew this way. Dwarf galaxies combining, larger galaxies clustering. Again in simulation, astronomers have built a picture of cosmic evolution. Telescopes can see back to shortly after the first galaxies formed. It's a story of continuous change, sparked by the Big Bang. But so far, the formation of the first galaxies, thought to be 500 million years later, has not been seen. Telescopes are yet to penetrate those cosmic dark ages. Here is as far as we get. We're zooming into apparently empty sky. But no, there are points of light beyond. The deeper we go, the farther back in time. It's a history of galaxies through the instruments of the Hubble Space Telescope, like drilling a core sample in a pinpoint of sky. Requiring 800 exposures, this is the deepest optical image ever obtained. Hubble reveals almost 10,000 galaxies. 100 of the smallest points are the most distant. Galaxies already formed 800 million years after the Big Bang. The oddest-shaped galaxies are from early times, when the universe was more chaotic. In contrast, closer and younger, this foreground spiral is rather ordinary. The universe has many mysteries, not least why it burst into life. This string of galaxies is another puzzle. Astronomers modeled it from 11 billion years ago. But how did such a massive structure develop so early? It defies our current understanding of cosmic evolution.